Welcome, everybody. We wanted to share the thing we did with the Grafana stack at the Dutch tax office. The little agenda for today. We're going to talk a bit about what we do. Of course, many people, I think, know for a bit what we do, but I'll give you some more details. We did a tender. I'm going to talk about that. And from the tender, we started a project to implement the Grafana stack. And during the project, we had to make some key decisions, and we want to explain them, run you through them, and then my colleague Bram will continue with the more technical part of what we did. Well, let's first introduce ourselves. My name is Frank van Herpt. I once started my work life as an IBM Tivoli consultant, worked with a lot of financial companies a long time ago. Joined the Dutch tax office because they were using the same tooling. And, well, time flies. 11 years later, product owner for the team, the monitoring team, and yeah, the IBM tooling is kind of gone. It's completely switched to open source Grafana, but we'll explain that later. Bram?
I'm Bram Schutte, Den Hollander. I started my career as a software engineer at the AV IT department in the luxury yachts. But 3 years ago, I joined the team of Frank, and I've never been happier there.
Thank you, Bram. Well, a little bit about the tax office, of course. Everyone knows us from the blue envelopes we send out. Behind that, there's a whole lot of operation going on, of course. Just to give some insights, every day, I checked it on the website, every day, €1 billion is collected in tax revenues. And of course, we do that to make the financial backbone of the government, of the country, stable, transparent. Supporting this mission, this goal is to a very dynamic, complex IT environment. We have thousands of interconnected systems doing millions of transactions every day. Of course, high standards for security, reliability, scalability, all running 24/7. Yeah, by some numbers here also, we have around 27,000 employees, which 4,000 only in IT. That's quite a number, I think. We run about 900 applications spread out on all kinds of platforms. Name it, and I think we have it, mainframe, OpenShift, Linux, Windows, etc. We find it difficult to say goodbye sometimes to the platforms. Yeah, about 18,000 VMs we use. Yeah, it's all running in our own two data centers. That's also good to know. We also have data centers we have to maintain ourselves also. So from the tax office, if it works, I'm going to our team. Our team is sitting there. We are at 6 FTE, including me, so 5 system engineers. Yeah, what you see at the tax office, we have a lot of monitoring tools. I mentioned the platforms. We have a mainframe with our own tooling. We have Windows with SCOM. Yeah, from the old days, we used to monitor Linux and AIX. That was our team main goal. We used expensive software for that, IBM software, BMC software. But I think 5-6 years ago, we made the switch to open source. We did the POC with Zabbix and Grafana to give the data to the teams, because Zabbix was not very good at that. So I think we have around 5 to 6 years experience with Grafana already, just the dashboarding tool, of course. Well, this is what we do in infrastructure monitoring. The other thing we do with our team is event management. We have like all the monitoring tools, but we have one rule: all events should come together at one place. Our operations bridge centrally manage all the interruptions we have, solve them. They do standby in the weekends, that kind of stuff. We do that using IBM Netcool. Don't know if people know it, but it's really nice software, handles events very good. The last service, the newest in our portfolio, this is we call APM, Application Performance Monitoring, or as you would call it, probably Observability. That's the stack we offer to teams. Now then I'm going to talk a bit about the history behind this. We have two teams, I think. Performance Competence Center, which main role is to be busy with improving, helping teams with performance. And the income tax chain, they wanted more insight in application performance. So I mentioned here 2018, I think we already tried to acquire the software. That we had to do a tender. Of course, we cannot buy software that we like. We have to write down all our demands. We have to publish it, and suppliers can make an offer and supply their products. After some very complicated formulas, compliancy, cost, we get a winner. It failed a couple of times, too expensive, legal issues. But we got a winner now, that was Grafana, and that was in 2023. And they offered us the Grafana LGTM stack in enterprise form with support on it, training, that kind of stuff. End of 2023, the tender was successful. We used 24 to implement the stack and to provide it as a service to other teams. And beginning of 2025, we are live with it. We had a couple of requirements I can highlight. It should be on-premise. Cloud was a big no-no at the tax office for a long time. It's getting more open now, but given the relations with the US, it's getting more complex now. And also, it should support open telemetry. So that's also a thing that we really like to have in the tender. Well, to implement such a project, it's kind of complex. So that's why a project was started. We always do that at the tax office. A project manager, they get some goals, and the goals were quite clear here, I think. Implement the product, of course, completely on-premise. We had to monitor an application with it, an MVP. The service should be reusable for other teams, so we should have like a example configuration available. And we should do a promotion tour. We should talk to teams, present it, do demos, that kind of stuff. Of course, in the project, we need other other teams, platforms, storage, networking, all those teams. So then it's nice that you have a product manager running that part. Because it's better, I think, to do the happy customers, do the talking. The first team that joined our stack, they were really happy with what it can offer, especially the tracing part. They really quickly solved some performance issue with it. So we let them do the talking also, because it's best to let the users spread the word, besides the more technical demos that we give. During this project, we had to make a lot of choices, and I have some highlighted here. Because we have the enterprise version of the LGTM stack, we have a tenant system included. The question now was, what is a tenant? You can make a tenant per team that wants to join the stack. Also, one of the requirements we had in the tender is we want like a chain level overview. So we want income tax. We want to see how the chain is doing. That's why we decided to do a tenant per chain. So I think we have like 15 chains, car tax, income tax, etc. And teams join under a chain. This has some disadvantages. Of course, because we have the enterprise product, we pay by data ingest. It was a bit more difficult to monitor that because we do it on tenant level. We cannot see what a team is sending in. So that's why we made a requirement to send in a required label, a team ID. With the label, Grafana helped us creating a dashboard in which you can see the data per team. So we still have insight in that. The other thing is that within a tenant, by default, the data is open, so teams can view each other's data. For some teams, it's a bit difficult, but we want a chain overview. The next one is Grafana Alloy. Alloy came out during the project. It was really a nice product because OpenTelemetry, Prometheus all combined. So we wanted to implement that. We had some choices. Are we going to do that centralized or let the teams do it themselves? And well, after discussions and advantages, disadvantages, we decided to let teams do it themselves. Otherwise, we had to put it down, Alloy, configure it, onboard teams in it, add tokens. All the maintenance is coming to our team. All of exceptions, data manipulations, we didn't want to do that. And also we wanted to make sure that teams empower use observability in their pipelines. So we provide installation examples, configuration examples. We provided, of the OpenShift team, provided the capability to run Alloy very quickly. And that's how we use Alloy. All the teams do it themselves, and we help them with it. Then we have security. We don't want unauthorized teams to send in data, so we go to an intake process. They fill in a form, I will contact them, we talk about 30 minutes about their plans, what they're going to do, platform they're on, what kind of data they want to send in, just check what they want to do and who they are. If we approve it, most of the time we do, they get the tokens and they can start sending in the data. From that, I'm going to enterprise and open source. What we noticed is we have tenants with the chains, we have applications below it, but we have a lot of generic data. For example, the OpenShift team, they collect metrics from all the clusters. It's not really under one tenant. If we would send it to the enterprise stack, it would also be a big gap in our license capacity. So we decided, well, let's build an LGTM stack, but then an open source version next to enterprise, send in those generic data to that stack. So now we have the enterprise stack for applications, open source for all generic data that teams can reuse in their dashboards. It's all available in the same front end, so it's quite easy to use. And it gives us the possibility to scale licensing, keep an eye on that. We still have added value from enterprise because we have an admin API we use. We have multi-tenancy system that works for us. And of course, enterprise plugins. Splunk is quite big at the tax office also. So Splunk plugin is nice to have. It's an enterprise plugin, and Jira also. So that still the enterprise version gives us advantages. From that, I'm going to give the word to Bram with a more technical insight on what we did.
Yeah, let's take a deep dive in what we deploy and how we did deploy it. Our setup consists of the LGTM stack plus Pyroscope, as Frank already mentioned. They won the tender, so we're going to implement that. At this time, we have two customer clusters running, one for the development, testing, and acceptance stage, and we have one completely dedicated to prod systems. For ourselves, we have two development clusters to test the lifecycle management, new features, and our custom tweaks that we implement. And as Frank already mentioned, we have two open source clusters for big data and for the chainless apps, as we used to call them. One example is the OpenShift team that is doing that kind of stuff. Our data as well, because we're not really part of a chain. We just want to make all the data that we consume public, so everyone can just watch it without any additional privileges. How we did deploy the clusters on the OpenShift cluster. We have, as we mentioned, an OpenShift team, which helped us a lot. On the left side, you can see all the applications that they provide us, so we don't have to be an admin on our own cluster. We can add merge requests with all the permissions that we need for the software to run properly, and then they will make sure that it's all implemented on the cluster. So we only have our own problems with application development and that kind of stuff, and not have to worry much about the cluster itself. To do that, we use the pass operator. This is also available on GitHub if you want to see how it works. And it's really valuable for us. So when we ingest a merge request, there's lots of information available. What is wrong with our request? What can we do better? How are we doing with our resources and that kind of stuff? To deploy the actual application on the cluster, we used Customize and Helm charts. And for the people that don't know what Helm charts are, it's essentially a recipe. We just say in the Helm chart, this is what we want. And the Helm chart will create all the stuff that is needed to make sure the deployment is okay to go. When we started, we didn't have much knowledge of the OpenShift cluster, so that was the best way to go for easily deployment. And we had a turnaround of 1 year, which is really nice for a government-operated team. You wouldn't say that, but it is. We, of course, the monitoring team also want to monitor what is happening on our stack. We call it MOM ourselves, but also meta monitoring is used as a term for that. What we do is we collect all the logs, metrics, and traces from our enterprise cluster, and we push it towards our OSS cluster. This makes sure that we don't take a huge chunk of our licenses, but also when the enterprise cluster is down, we can still see what is happening, what the logging is saying, and all the traces, and our dashboarding still works. The backend resources can be scaled way more towards what the customers need instead of what we expect to need, because all the huge data is pushed to the OSS cluster, so the important data is not really impacted by all the changes that we do. We built a piece of custom software ourselves. We called it LGTM Automate. And this piece of software is created so we can easily deploy a new team on our cluster. It will take approximately 1 minute to add a team to our Bitbucket repo. And then the software will read that repo and will communicate to the admin APIs with the steps on the left side, as you can see. It creates an access policy, tenant token, team folder, data source, and then at the end sets all the accesses so the teams can have the chain overview that we wanted in the first place. When we started this project, Grafana Alloy was introduced in version 1.0, and it couldn't have come better for us. At that time, we were still seeing what we wanted to use, if we wanted to use Kafka or OpenTelemetry collector. But we decided to use Alloy because it's essentially an OTel collector with a fancy jacket on and a whole load of support from Grafana. So we decided to go that way because of the OTel compatibility. And in the Dutch tax office, there was already some stones rolling for the OTel compatibility. So we decided, this is our way to go. Alloy also supports some dynamic monitoring, especially for OpenShift clusters. So you can deploy one configuration, and it will scan for all the pods and all the services that are running. So you have the collection of the data without any additional configuration when something changes on the cluster. It essentially is agentless, as we like to call it. We can do some remote monitoring without deploying the Grafana Alloy everywhere. We can just put the configuration in one Alloy, and it will reach out to all the different kind of services that we want to monitor. One advantage is Alloy has already baked-in support for many applications and for many services that we use. As Frank mentioned, we have like services running that are from the 90s, and we still need to support that for our monitoring. So having all this compatibility and the monitoring for all the solutions is really valuable to us. So that's why we use Alloy. Some of the obstacles we face during our deployment is, of course, our legacy database that we'll have at the Dutch tax office. It's enormous, and we're still running into issues today that teams are knocking on the door and say, oh, I still have RHEL 7 running, and what do I need to do to have this monitored? We try to help other teams with the Alloy configuration because it sometimes can be a bit confusing. But with the huge platforms we have and many programming languages, it's hard to have a generic example for teams that they can use and adapt for themselves. We're still figuring out how we can do it best to make like many different examples or one big one. We still don't know what the best option is, but we're still trying. We also have forced labeling. As Frank mentioned, we tried to have the chain overview and teams sending data under a chain. But the downside is that we don't know where the data is coming from, because we don't know which team is sending it in and who to contact. So we decided to approach the teams that they should force labeling into their data that they ingest, like a team name or a team solution group. But we noticed that 80% of the teams that are connected still aren't doing that. And we don't know who to contact. So still an ongoing issue. And of course, the last part, what is useful data? Everyone is having this problem because it's easy to enable, let's say, the metrics and push it to the stack. But what are you going to use? What is things that we can throw away? What is things that we can filter out? How can we manipulate data so none of their social security numbers are leaking out? Very important stuff, but still ongoing challenge, and we still trying to figure out how we can help teams with these problems. And Frank will conclude this talk.
Yes, with that, by Bram. Thank you, Bram. We want to make a little conclusion. First of all, the stack is very stable and reliable for us. It's all on-premise, but it's working very good. No crashing, no performance issues. So we're very happy with that. Also, upgrading it's just very easy. So that's one thing I wanted to mention. This is combined with the flexible architecture. You can combine enterprise features with open source. It really benefits for us. New insights. This is what we notice with the teams that are connecting to it. They really get new insights, especially the tracing, profiling. They really pinpoint their problems more quickly than before. They used to have scattered tools, maybe a Jaker or whatever, downloaded from the internet. Now we have a central platform, and we see that teams are embracing it. We went from, I think, 0 to 250 users in this to the 25, so it's really picking on. So we are very happy with that. And the last one is we really want to empower teams to do it themselves. Think about how you're going to monitor your stack when you migrate your application to OpenShift. Think about this, bring Alloy with it, and that's what we're trying to do. I think we told what we wanted to tell, and we have some time for questions.